Welcome to the part 8 of the MSP432 MCU's training series. In this section, we will cover the software solutions available on MSP432. If there's only one thing to take away, is that everything software related is provided inside MSPware. So MSPware is a collection of all software, documentation, application notes, training, collaterals, and so on and so forth. Everything is provided within the MSPware collection. MSPware is available as a standalone download. It is also available inside CMSIS or Code Composer Studio. It is also available on the TI's cloud development tools inside TI Resource Explorer. So within MSPware, you can find information on MSP432, including user guide, training, application notes, and other libraries. The very first and fundamental building block of any software on an embedded platform is the register-level code. So MSP Register-Level code is fully provided on MSP432. So any of the traditional MSP code example that you have learned to know and love, fully available. Using the device header file, you will get access to the complete register and bit definition. Since many peripherals are being shared across MSP430 and MSP432 platform, the register as well as the bit definitions for these peripherals are also fully compatible. This enables for complete portability across common peripherals such as Timer A or EUSCI. Out of the box, more than hundreds of code examples are already provided for the peripherals that are available on MSP432. You can browse through any of these simple C code examples to learn how to manipulate and control different peripherals. For example, below is a very simple code example used to control the ADC14 module using the register level access style. In addition to register access code, the MSP432 also provides driver library, which is a collection of highly abstracted APIs that enables higher level programming, which might be suitable for several software engineers in more complex software applications. So driver library offers easy to use and easy to understand functions. Developers no longer need to read the cryptic registers, bit and definitions to configure different peripherals. And again, since MSP430 and MSP432 families share many peripherals, the DriverLib APIs are also shared across the different family platforms. This will reduce the porting effort if you already have an existing MSP430 application using driver library. You can see here an example of how driver library condensed the code for the software programmer. On the very top is what the code looks like on driver library. Two functions are required to fully configure the timer to generate PWM. When using traditional register level C code, several instructions are required, and as you can see, many of these values are harder to digest and harder to understand. Since MSP432 driver library was developed along the same time as the chip was designed, the library has been fully tested to prove its robustness and efficiency. For that reason, MSP432 driver library was programmed directly into ROM. That way, developers can access the driver library either as ROM or as source code. Even though the ROM version is really robust and proven to work with the latest version of silicon, there are always opportunities to enhance existing APIs with new features or extend the API set to have new function calls with new capabilities. For this reason, some developers might choose to use the MSP432 driver library as source. It is available fully as open source using BSD's license, and it's completely up to the users to further customize, enhance, or add new functionalities to the driver library. On the other hand, many developers might find the MSP432 DriverLib in ROM suitable for their application. In addition to proven robustness, DriverLib in ROM has a few additional benefits. First of all, ROM execution has lower current consumption compared to Flash. In addition, ROM requires no wait state even at the max speed of 48 MHz. Using peripheral driver library in ROM, we also free up the flash space of roughly 25 kilobytes for application code. With these three reasons, using DriverLib in ROM will free up the space for your code, consumes less power for the device, and can perform at a higher speed compared to Flash when the device is running at maximum speed. Now at this point you might ask, but the source is always newer than the ROM, so how do I know when to use what? As a rule of thumb, it is always best to use the latest version. Most of the time ROM APIs will not be changed because it has been fully tested, but sometimes due to new enhancement, the source version might be preferable. For that reason, an intermediate layer has been created called the map layer, and this map layer will always point to ROM if it is the latest version. If not, it will point to the source version, which might be a newer version of the API or a completely brand new API altogether. So if the developers always choose to use the map version of the same API, they are guaranteed to either use the ROM version, the most robust version, or the latest version if that's available in the source code. This is actually very easy to use in reality. The three ways of using the DriverLib calling conventions are: if you want to use the source code, simply have no prefix. So the API call will be something like this: _generate PWM, essentially peripheral name underscore the function name. If you explicitly want to use a DriverLib ROM function, if you know for the fact that the ROM function is what you want to use and it is the latest and greatest version of the API, you can use the prefix ROM underscore in front of the function name. Now, the smartest way to use the DriverLib API is to use the map function. So the API call will now be map underscore generate PWM. Using this map version, you are guaranteed to use the ROM if possible, or the latest version in the source code. In addition to providing the traditional register access code as well as driver library, MSP432 is also fully compliant to the Cortex microcontroller software interface standard for CMSIS, since MSP432 is also a Cortex-M microcontroller. So CMSIS is a standardized hardware abstraction layer for the Cortex-M processors. With CMSIS, you can leverage the CMSIS header file, CMSIS intrinsic functions, as well as higher abstracted libraries such as DSP, RTOS, and so on and so forth. As an MSP432 user, developers can use a mixture of register access code, driver library code, as well as CMSIS libraries. Here's one example of how that mixture comes into play. From the core, the MSP432 header file provides the MSP definitions where you have control over each and every register bits as well as registers. At the same time, the header file also provides a CMSIS definition of the same registers where everything is organized into structs. Again, by providing both types of definitions, MSP430 devices enable users to be really flexible and be able to mix and match the software style they use for the application. For example, some user might find some existing MSP430 code that they want to copy over to MSP432 for Timer A configuration. At the same time, they can also mix with MSP432 driver library code for more complex peripherals such as DMA or ADC. And finally, they can also mix in some CMSIS style code that they just happen to find online for different ARM devices. In addition to the low-level libraries and header files, MSP432 also provides a wide range of high-level libraries that developers can leverage to quickly build a robust and efficient base system so that they can focus more energy on their unique applications. So as mentioned before, all of these libraries and examples are all located inside MSPware. So you can go into MSPware to find out more information about these libraries, such as graphics library, capacitive touch library, IQ Math, or more application-centric libraries such as NFC, CC3100 Wi-Fi, SimpleLink, BLE, Bluetooth, and so on and so forth. For more complex MSP432 applications that require resource management with multiple components, peripherals, and tasks running in parallel, there are also a wide variety of real-time operating systems that the users can use for MSP432. Some of this real-time operating system include the TI FreeRTOS or the Micro OS, and there are many more that are being developed and introduced into the MSP432 software ecosystem. For more information on these libraries, I definitely recommend browsing through MSPware. Again, you can find MSPware as a standalone download on the TI's Cloud Development Tools website, inside TI Resource Explorer, or inside CCS or Code Composer Studio IDE. In here, you can find different MSP432 libraries such as the DriverLib, graphics library, and so on and so forth. You can find more information about the real-time operating systems, as well as code examples and demo projects that can be used to demonstrate different capabilities of these libraries. With that, we have concluded the part number 8 of the MSP432 MCU training series covering software solutions on MSP432. Thanks for watching.